This is lectures on the second sections of chapter 1 is about data classifications. In this sections, we'll talk about how data are classified into different types and also into different levels of measurement. First, when we talk about data, there's two types of data. First is qualitative data. So qualitative data consists of like attributes, labels, or non-numerical entries. For examples, if you ask questions, what is your eye color? Your answer should be blue, black, or brown. So those are qualitative data. Or what is your car models? What is your majors, and so on and so forth. And then the second types of data is quantitative data. So quantitative data consists of numerical measurement or count of your data. And in quantitative data, there's two different types of quantitative data. The first type is continuous data. So if you have a continuous data, that means that those data can be measured, right? And then have infinite number of possible values within those measurements, infinite number of possible values within those measurements. As you can think of percentage, you can think of ratios, you can think of decimals, numbers are the values of continuous data. So for an example, you can measure the amount of precipitations in millimeters. Or you can measure your height, right, in terms using inches and feet. You can measure your weight using pounds. You can measure the length of a certain object. You can measure temperatures and so on and so forth. And the second type of quantitative data is discrete data. Discrete data are the data that can be counted by whole numbers as the whole can be counted. For example, you want to count the number of COVID-19 cases. You're given 5, I think updated today is 80,000, something like that, right? Or the number of students in a particular school or number of students in particular class, etc. So those are discrete data. And then within the data types, you can break the data into different levels of measurements. Let's say there's 4 different levels of measurements. The first level is nominal level. So only qualitative data can be classified in nominal level. If you use data to categorize using names or labels or qualities or any of non-mathematical computations, data is nominal level. Okay? An example is a list of TV shows or species of trees in the forest. And when you list all the TV shows, you're using labels like names, right? The same as species of trees. You're not using any numerical measurements. The second level is ordinal level. So in ordinal level, both quantitative or qualitative data can be classified at the ordinal level, okay? And this data can be arranged in order, can be ranked, but the differences between the two data entries are not meaningful. If you have a quantitative data that is at the ordinal level, then the difference between the two entries of those quantitative data should not give you any meaning at all. Okay. For example, if you look at the pain scale level from 0 to 10, you use numerical measurements to measure your pain scale, but when you take, and it's in order, right? From 0 to 10, that means 0 is like the least painful and 10 is the most painful experience. But then when you take the difference between 10 and 5, you get 5. You cannot get any meaningful interpretations for that difference, because the difference between 10 and 5 is the same as the difference between 8 and 3. And how can you get any meaningful interpretations from those differences? That means the pain scale level, let's say from 0 to 10, is at the ordinal level. Or if you look at the top 5 business schools in the US, so you have a list of 5 business schools ranking from 1st, 2nd, 3rd, 4th, and 5th, then those data are at the ordinal level, even though that data is qualitative data, but it's at the ordinal level because it has strength. All right, so the next level is interval level. So interval levels, only quantitative data can be classified at the interval level. So in this data can be ordered, right? And the meaningful differences between the 2 data entries can be calculated and give you some meaning, some useful meaning. The difference between 2 data entries can be some useful meaning. One thing about this data, this interval level is 0 is not an inherent 0. That means 0 doesn't mean empty, and it's just the positions on the scale. For an example, if you want to ask what is the times of the day when a person checks email, you can say around 8 o'clock, around 10 o'clock, around noon, around 2 p.m., around 5 p.m., around 9 o'clock at night, right? So you given like the times of the day, those are numerical, quantitative data. And if you take the difference between the 2 values, let's say from 10 to 8, right? Then you have 2 hours. You can say that this person check his or her email in every 2 hours, from 8 to 10, and then noon, and then 2, and then 4, and 6, and 8, and so on and so forth. Okay. And the next example is the years of the US recessions. The years is mean in 1920, you have a recessions, or you have another recession, like the recent recessions is in 2008. And if you're giving a list of years of the US recessions, those are quantitative, right? Because you're using numerical measurements. And those are at interval level because they can be in order, they can be ordered. And if you take the difference between the 2 years, you can say this is the number of years apart where the US were experienced recessions. Then the difference between the 2 data give you a useful meaning, and you can interpret that meaning. And again, years is not a 0. Year of 0 is not, it doesn't mean that there's no time before 0. It doesn't mean that this empty year at the times is empty at year of 0. It just 0 is a scale. It's a positions on the scale. Okay. Another examples of interval level is temperatures. Is quantitative. Yes, temperatures right here. It's quantitative, can be order. Difference between 2 entries are meaningful. And also 0, it's just a position on the scale. When you're talking about temperature, 0 doesn't mean there's no heat. Okay. All right, the last level of measurement is ratio level. So the ratio levels data that is classified at the ratio level is very similar to the interval level, with one added property, that 0 is actually an inherent 0. That means 0 means empty. And also the ratio of the two data entries can be formed meaningfully. If you take the ratio of the two data entry, you can interpret one as the multiples of the other one. Right. And here is a table that provides a summary of the 4 levels of measurements with 4 different levels here and examples of the data set and some meaningful calculation that you can look at. Now let's do an exercise. So the first exercise is you have a list of entries, right? These entries here appear on an employment applications. So for each of the entry or each of the item, you want to classify the data. What is the type of the data and what is the level of measurement of the data for each category, for each entry? First, they ask, what is the highest grade level completed? Possible options are a high school diploma, associate degree, a 4-year degree, a master degree, or a PhD degree. So if you look at this possible responses for these questions, so these responses here are non-numerical responses, right? They're just names or labels. That means the types of this data should be qualitative. And the level of this data should be ordinal, because these categories can be ranked from lowest to the highest. Lowest to the highest. And the next part, the next category is the next entry, gender. So, and I guess the genders, the possible answer for genders, again, just no numerical responses will be involved here. That means we have the data type for gender is qualitative, and there's no ranked among genders. That means the level of measurements for this data is nominal. Okay. And then year of college graduations. When you're collecting year, keep in mind that it's quantitative and also it's interval when year is the data that you're collecting. And then the number of years at your last job, the number of years at your last job. You know that is quantitative because it's collecting numerical responses, and the level of measurement should be ratio, because 0, the number of years at the last job, 0 means empty. That means you don't have any job up to this point, right?